Thanks for tuning in to the Oxygen Alliance YouTube channel where we share the Concentrator Talk virtual meeting hosted every Thursday from 2 to 3 p.m. Central African Time. In the talk, we discuss different aspects of oxygen concentrator assessment, use, and maintenance. And please don't forget to subscribe and hit that notifications bell.
Hello everyone, and welcome back to the Concentrator Talk call brought to you by the Oxygen Alliance. My name is Naomi Thompson, and I'm currently in Lilongwe, Malawi, and I'll be your host today. Joining me are my colleagues Maui Lungu and Sharon Ngozo, and we'll be with our usual technicians from Open02 and Sunrise. On the technicians panel today, we have Paulina Muhosho, Masofa Mujaji, Kowinda Singh, Kelvin Saidi, Brenda Luhanga, Dominic Mapanji, and Eunice Msisya. In case you're just joining us for the first time, the Concentrator Talk Call is a virtual meeting hosted by the Oxygen Alliance every Thursday from 2 to 3 p.m. Central African Time. And here, we discuss various aspects of oxygen concentrators, assessment, maintenance, and their use. So feel very welcome, and let's stay together to the end of the call. If you have any problems regarding your oxygen concentrator, in regards of maintenance, assessment, and their use, you have come to the right place. You can get in touch with us through our email, info@oxygenalliance.org, and our technicians will do their very best to assist you with the right solutions. In case you have any questions during the call, you can simply raise your hand and come off mute and ask the questions, or you can paste them in the chat and our technicians will do their very best to answer them. We normally have a topic of interest, and today, Kelvin Saidi will be talking about the purging process in oxygen concentrators. So make sure you're there to listen to all that we have prepared for you today. Without further ado, we jump into our questions. Our first question reads, hello, I'm a biomedical intern at Kamuzu Central Hospital. I've been working on a number of oxygen concentrators, and I have noticed that most of them do not have the earth wire. I have learned that earthing equipment is very important because it avoids users from electrocution. Why is it that oxygen concentrators do not have the earthing as a machine? So I'll ask one of our technicians to respond to that question as to why oxygen concentrators do not have the earthing wire. Okay, so we have a hand from Kowinda. You go ahead.
Thank you very much for the question, Naomi. Earthing can be simply defined as providing a path of low resistance for the leakage current to the earth. It is true that if a device is not properly earthed, it may lead to harm both the user and the device itself. Therefore, it is really important to use equipment that is properly earthed. To answer your question, the reason why most oxygen concentrators do not have an earth cable is that they are designed so that they leave the live wire can never cause electrical shock, even if they touch the casing. This is because these machines are double insulated. Devices that are double insulated have a symbol consisting of two squares, one inside the other. If you look on the data plate of a concentrator, you are sure to find this symbol. As this name suggests, double insulation means that there is an additional insulation on top of the insulated wires. This is mostly achieved by using a plastic casing. Plastic does not conduct electricity. Therefore, even if there is some leakage current leakage, the plastic casing of the concentrator will not conduct electricity, hence saving the users from any electrical shocks. Thank you, Naomi.
Thank you very much, Paulina, for that response. Do we have any comments or questions, follow-up questions for the explanation that Paulina has just given us? Okay, so we move on to our next question. Our next question reads, hello, I was working on a J5 concentrator that registered low purity. After some troubleshooting, I found out that the low purity LED still lit on even though my analyzer indicated a purity of 95.6%. I tried to use various analyzers just to be sure that the fault was not on my side. All the analyzers indicated a high purity. I concluded that the sensor is faulty. The problem is that the concentrator is urgently needed in the wards. Can I just remove the low purity LED and give the concentrator back since it's working properly? So I'll ask one of our technicians to respond to that question. Okay, we have a hand from Brenda. Go ahead.
So thank you for that question. So the problem of faulty sensors is one of the most common problems faced when fixing oxygen concentrators. Sometimes, like in your case, we may not have the replacement for this sensor. The LEDs on the concentrators are there to alert the user if something goes wrong in the concentrator, like for example low purity, high or low pressure, just to mention a few. So to bypass this, would be equivalent to destroying the only means of communicating with your machine, and this may lead to a catastrophe. It's said that two wrongs do not equal to a right. So the removal of the purity LED and the malfunctioning oxygen sensor are both errors, and the result will always be bad. So in your case, you are sure that the sensor is faulty and the machine is producing high quality oxygen. If the machine is urgently needed, you can deliver it to the ward. Before this, you should put a sticker to notify the users that the machine is for emergencies only. Since oxygen purity drops over time, I also advise that you monitor the concentrator frequently, maybe once every week, by checking the purity with an oxygen analyzer and making sure that it's within the recommended range. This should not be a permanent fix, however, and make sure you procure the suitable replacement of the oxygen sensor. Thank you.
Thank you very much, Brenda, for that wonderful response. Indeed, two wrongs do not make a right. So you need to find a replacement for the sensor so that it can be able to work well, and you can also be able to communicate with your machine, as Brenda has put it. So do we have any follow-up questions or comments? We can just raise up our hand and you come off mute. Okay, seems like that was well explained. So we move on to our next question. Our next question reads, hello, we have a pair of non-refillable seat beds that need to be refilled. Is it possible to modify such beds and to be able to refill them? Is it possible to modify non-refillable seat beds and modify them? So I'll ask one of our technicians to respond to that question. Any first one? Okay, we have a hand from Kelvin Saidi. Take the floor.
Thank you, Naomi, and thank you for the question. I'm sure that you're all aware of the types of seatbelts that we have, which are refillable and non-refillable seatbelts. So it is possible to modify the non-refillable seatbelts from your concentrator. This process just needs you to have some required tools for removing the end cap and materials for coming up with the replacement caps. So I'll outline the steps and the necessary tools you need for this process. So as you can see in the graphics, that is an example of a non-refillable seatbelt. Okay. Firstly, you need a wooden jig to secure the seatbelt in place as it is being cut. So you place the seatbelt in the jig as it is shown in the graphics. The jig has a marking at the very end that shows where the bed should be cut. And using a hacksaw, cut the seatbelt to remove the spring. Caution should be taken when doing this, since the spring can fly out and hit those who are around you. So the spring cap, disc, and filter should be kept, for they will be used when refilling the bed. You also need a drilling machine to drill in the holes for the screws that will hold the cap in place when the bed has been refilled. So these are self-tapping 10mm screws installed at 120 degrees. So there's also a graphic showing a seatbelt that has been cut and holes drilled in it. So cutting off the end of the seatbelt will mean that the cap cannot be replaced and held in place for the bed. So you will therefore need a custom-made PVC plug to act as a cup holder, and this will be placed above the cap that was there at first when closing the bed. The plug needs to be drilled in the sides, just like the bed itself, to allow the screws to fit in. After you've refilled the bed, you place the filter together with the disc, followed by the spring. Then using the seatbelt refilling jig, hold down the plastic cap that was on the bed together with the PVC plug that has been made and tighten the screws in the sides. Once your refilling process is done, follow the normal procedure of checking for leaks on the bed, especially when the modification has been done, and you can check for the leaks using soapy water. So in the graphics, you can see what a refilled seatbelt looks like. Thank you. Over to you now.
Thank you very much, Kelvin, for that wonderful explanation. Do you have any additional comments or questions? It really is indeed expensive to replace the whole seatbelt to buy the seatbelt. So the processes that Kelvin has helped us with can really help us in running away from other costs that are there in replacing the whole seatbelt. We can simply just cut it off and make modifications, which is much cheaper than buying. So do we have any follow-up questions or comments? Okay, so we move on to our next question. Our next question reads, I was working on a W+515 oxygen concentrator, which was overheating. After troubleshooting, I found out that the cooling fan was faulty. I replaced the cooling fan, but despite this, it was still overheating. I checked the compressor service kit and they were okay. I also checked the intake and the gross particle filter and they were also okay. What can be the cause of this? So I'll ask one of our technicians to respond to this question. We have a hand from Masofa. Go ahead.
Thank you, Naomi. A developed 151 cooling system works by taking hot air in the concentrator and discharging it into the atmosphere using a fan. If a fan is faulty, it does not spin and the hot air accumulates, and therefore the temperature in the machine becomes too much and the unit start overheating. In your case, you have stated that you have replaced a faulty cooling fan with a new one, but the problem still persists. Despite cooling fans having the same voltage rating, they may differ in cooling capacity. In this case, it is how much air they can move from the concentrator to the atmosphere. All cooling fans have a rated speed at which they rotate, and this is measured in revolutions per minute. The air equipment company state that within a fixed system, the higher the revolutions per minute, the more air it can move. I advise you to check the rotation speed of the new cooling fan that you have just installed and compare it to the original one. You need to get a cooling fan which with a rotating speed equal to the one you replaced or higher than the one you just replaced, so that you can have the problem solved. Thank you.
Thank you very much, Masopa, for that wonderful response. Before replacing any component in the oxygen concentrators, we need to check their ratings and we need to check if they're compatible with the one that was previously there. So that is very important. Thank you very much. Do we have any comments or questions? Okay, so we move on to our next question. The next question reads, hello, I'm a biomedical intern at a certain hospital and I'm working with a J5 concentrator that is not powering on. After some troubleshooting, I realized that the fuse just after the power socket was damaged. The problem is that I do not have the specific fuse required that is 7 amps, but then I have a 3.5 fuse available at the workshop. Can I arrange 2 of these in parallel to replace the damaged one? So I'll ask one of our technicians to also help us out with this question. We have a first hand from Dominic. So take it away.
Okay, thank you for that question. So I'm assuming that you have suggested this alternative because of the fact that current is shared among parallel roads. So as we might be aware, current in a parallel circuit will be shared depending on the resistance ratios. Now this is according to the Ohm's law, yeah? So this means that the branch with lower resistance will allow more current to pass through it. So you have suggested arranging 2 3.5 amps fuses so that the 7 amps can be shared among the 2 fuses. This is a very good idea, and in theory, it should work. But then, practically speaking, 2 fuses of the same rating will not have the same composition, and this means that their internal resistance will vary. So the varying resistance will mean that more current will flow through one branch, which will eventually blow it. And shortly after, the second one will also blow up, since it will carry the whole 7 amps of current. So for this to work, factors like fuse holders, length, and type of wire used have to be completely identical, which can be a challenge. So in this situation, you suggested your suggestion would be good for a scenario where 3.5 amps loads were being driven by 7 amps fuse. Otherwise, I wouldn't recommend this to be done. Thank you.
Thank you very much, Dominic, for that response. So things on paper and things on the ground. We really need to have our facts right when we want to transfer what we have on paper into the ground. So a reminder to those that are joining us for the first time, if you have any questions, you can simply paste them in the chat, or you can come off mute, raise your hand, come off mute, and then ask your question and we'll tend to it. If you have any questions pertaining to the use, maintenance, and assessment of your oxygen concentrator, you can send them through our email, info@oxygenalliance.org. And also, don't forget to share with us your email addresses so that we can add you to the emailing list that you get notifications of our new activities. Right now, we'll take a diversion into our topic of interest, and Kelvin Saidi will be taking us through the purging process in the oxygen concentrators. Let's learn together. Kelvin, the floor is yours.
Thank you, Naomi. So in today's topic of interest, we'll be talking about the purging process. So as an introduction, I'll explain some of the processes that happen in an oxygen concentrator. So there are a lot of processes that happen in an oxygen concentrator to ensure that it produces a high oxygen purity. Oxygen concentrators operate under a principle of pressure swing adsorption, where ambient air is drawn from the surrounding via the gross particle filter and the intake filter into the compressor. The air is then compressed and fed to one of the sieve beds at a high pressure. And normally this pressure ranges between 20 to 30 psi. The zeolite then absorbs the nitrogen from the air, and then this nitrogen is exhausted via the exhaust muffler. The feeding and exhaust cycles of the sieve beds are controlled by valves, such as the solenoid valve, rotary valve, just to mention a few. And this varies depending on the model of oxygen concentrator. So feeding, otherwise known as pressurization, is a process where compressed air is directed to one of the sieve beds at higher pressure for the absorption of nitrogen during the pressure swing adsorption process. For more information on this, you can check the topic of interest that was discussed on the 6th of October 2022. So I'll paste the link in the chat so that you can check it out in your own time. Now, moving on. Exhausting, or otherwise known as depressurization, is a process where nitrogen is removed from the seabed through the exhaust muffler. And it is important to note that the pressurization and depressurization process happen in an alternating sequence. So after the depressurization process, the seabed is at low pressure, and while most of the nitrogen gets back into the air during this cycle, there is some residual nitrogen in the seabed that needs to be forced out. And the process of forcing out this residual nitrogen from the seabed is called purging, and this is our topic of interest. So purging happens for two purposes. The first purpose is to equalize the pressures in the seabeds so that the bed that was just depressurized does not start at zero pressure for the PSA process, pressure swing absorption. The second reason is to remove excess nitrogen from the seabed for a production of higher oxygen purity. Purging is an important process in the oxygen concentrator, and we should note that it is different from the depressurization process. So now I'll take you through the process of purging in various models of oxygen concentrators. So depending on the type of oxygen concentrator, different methods are used to accomplish the purging process. Some concentrator models, including the ASEP and InvaCare models, use what we call an equalization valve, while models like the DeVopis 525 and 515 use an orifice. So an orifice can be defined as a small opening or restriction in a pipe or passageway that controls the flow of fluid or gas through it. And typically, depending on the type, an orifice can be used to regulate the pressure, flow rate, and velocity of the fluid or gas as it moves through the system. But in oxygen concentrators, the orifice allows a small amount of oxygen to pass through the other bed to help in the purging process. So the positioning of the orifice depends on the model of oxygen concentrator. Some oxygen concentrators have an orifice placed in the pipe connecting one seabed with the other, such as in the J5, while others have it in the pipe connecting the seabed and the equalization valve, such as in the AirSafe. So as you can see in the graphics, the arrows pointing to two orifices that help in the purging process. And in the 515, the orifice is located just after one of the seabeds, whereas in the DeVopis 525, the orifice is connected between the two seabeds. So in this piping system, it is connected where the arrow is pointing. So moving on, so to summarize this, the orifice is located between the seabeds. So as one bed is pressurizing, some of the oxygen produced passes through the orifice and pushes away the residual nitrogen of the depressurizing bed, and thereby achieving the process of purging. While other models use these orifices, some models use what we call an equalization valve for the purging process. So as you can see in the graphics, that arrow is pointing to the equalizer valve in an air-safe oxygen concentrator. So to understand the purpose of this equalizer valve, I'll explain the cycles that occur in an air-safe oxygen concentrator. So there are 5 valves of an air-safe model. oxygen concentrator, and these are the equalization valve, the left feed valve, the left waste valve, the right feed valve, and the right waste valve. So in the graphics, you can see a block diagram for an oxygen concentrator. So I will explain that below. So two valves are always open at the same time, and as sieve bed 1 gets fed with air, sieve bed 2 gets depressurized to release the nitrogen from the sieve bed. And after some seconds, sieve bed 1 gets saturated with nitrogen due to the pressure swing absorption process, and now the sieve bed 2 has to be fed. But before sieve bed 2 starts to be fed, the pressure from sieve bed 1 is shared to sieve bed 2, so that when feeding sieve bed 2, it doesn't start all the way from 0 psi. So when the equalizer valve is on, the pressure is shared between the two sieve beds. So this means that if the pressure was 30 psi, when sieve bed 1 was being fed up, the pressure in the two sieve beds would be 15 psi. Hence, the pressure has been equalized. So the equalizer is on for a period of 2 seconds in the AirSafe model. It is also important to note that equalization still takes place in other models of oxygen concentrators that do not have the orifice as well. For such models, the equalization happens at the bottom of the sieve bed, where you have the four-way solenoid valve or the rotary valve. When the orifice is not present, it can lead to low oxygen purity. So just by outlining the use of an orifice, I think you can get it, because the orifice restricts airflow for the paging of the sieve bed. And so if it is not available, a lot of oxygen will be directed to the sieve bed and less can go to the product tank. So in other words, you will be wasting oxygen that has already been produced by the sieve bed. So like I explained, paging also helps in equalizing the pressure so that the depressurized bed does not start at 0 pressure for the PSA process. So if it is not present, the sieve bed that was just depressurized will not receive the right amount of oxygen to elevate the pressure of the sieve bed from 0. Therefore, the pressure swing absorption will be affected, and less nitrogen might be absorbed, and this leads to low oxygen purity. That marks the end of this topic of interest. Thank you. Over to you now.
Thank you very much, Kelvin. That was well detailed, and I hope everyone on the call has been able to learn and understand the purging process in oxygen concentrators. Thank you. Do we have any questions pertaining to the topic of interest or comments? Okay, seems like that was well understood by everyone. Thank you very much once again, Kelvin. So from our topic of interest, we will jump back into our questions. And our next question reads, hello, I was troubleshooting an AirSafe New Life Intensity 5 liters concentrator, which was producing low oxygen purity, and the purity was 51%. So I serviced the compressor, filled the sieve beds, and inspected the tubings for leaks, but the purity wouldn't increase. As I was inspecting the concentrator, I noticed a label indicating that it was 8-liter machine, but the flow meter labeled was a maximum of 5 liters. Can this be the cause of the purity not improving or not? If that's true, how is it affecting the purity? So I'll ask one of our technicians to respond to that question. Okay, we have a hand from Kowinda. Go ahead, Kowinda.
Thank you, Nami, for the question. According to what you have said, it's possible that some of the concentrator's components were replaced. The control board or the flow meter are the components that I suspect. So in the original concentrator, flow meter was replaced with a 5-liter flow meter. So the purity should have improved. This is true because the concentrator would be running at a flow rate that is lower than its maximum flow. So when reducing flow, purity increases. The control board from a 5-liter machine was most likely substituted. This would explain why, despite your best efforts, the purity was not increasing. It is not advisable to do this because the 5-liter and the 8-liter concentrators are completely different machines. Components like the product tank, seabed, and compressor differ in these machines. Therefore, exchanging the control boards would lead to the chaos. The 5-liter machine pressurizes each seabed for nearly 6 seconds before switching, compared to 9 seconds for an 8-liter oxygen concentrator machine. So if the circuit boards were changed, pressurizing the seabed would only occur for about 6 seconds instead of the original 9 seconds. Low pressure in the seabeds as a result could I have caused ineffective pressure swing adsorption. Low oxygen purity would result. I advise that you inspect the time it takes for each bed to pressurize, switching times for the oxygen concentrator. If it switches seabeds after 6 seconds, that will tell you that it is a 5-liter model control board. So remove the control board and try replacing it with that of an 8-liter machine. I am sure the performance of your machine is going to change. You need to be extra careful when replacing control boards of any oxygen concentrator, making sure the replacement is of the exact model as on you are working on. Thank you.
Thank you very much, Kowinda. We have a hand from Eunice. Yes, Eunice, go ahead.
So I just wanted to add on what Kowinda has explained. It is really very important to make sure that you are using the right type of control board. So I just wanted to also point out that in the DevOps 515 and 525 models, despite both models being rated 5 liters, they use different control boards. So just make sure that if you're dealing with DevOps concentrators, you need to have a closer look and take into consideration the model of the concentrator, if it's either 525 or 515. Thank you.
Okay, thank you very much, Eunice, for that addition. Do we have any follow-up questions or comments? We really need to watch what we replace to the components that have failed in our concentrators, because in the end, we end up having concentrators that are not functioning well. Okay, seems like we have none. And at the end of this question, we have 2 polls, and I'll call on Mwawi to launch the polls. He is also going to explain how we can assess the polls and how we can also vote. So Mwawi, the floor is yours.
Thank you, Naomi. But before I start, I see Kowinda has a hand. I don't know if he has another extra comment, maybe.
No, it was earlier one only. Nothing.
All right. Okay, so I will be launching our first poll, and the first poll says, have you ever replaced a control board for an air-safe oxygen concentrator? So I'm going to leave it open for people to vote, and as we do that, in case you don't know how to access the polls, if you're joining us from your computer, if you go on the bottom right of your screen, there is an activities button. It's a triangle, a square, and a circle stuck together. If you click on that, it opens up a window where the pause menu is one of the listed options. And if you're joining us from your mobile phone, then you go on the bottom right of your screen and click on the menus options, the 3 dots. That will open up a window where you have the activities button as one of the listed options. And if you click on the activities button, it will take you to another menu where the pause menu is listed. And as people are voting on the first poll, I am also just going to launch our second poll, which says, did you know that the DeVilbiss 515 and 525 use different control boards? So I guess this is in line with the comment that Eunice has just made. So did you know that the DeVilbiss 525 and 515 use different control boards? So for our first poll, which talks about the AirSafe control board, it seems most of us haven't done this before, and just a few people have ever changed an AirSafe control board before. So for those of you who haven't done this before, I guess now you know what to look out for and the things that you need to consider when you're changing the boards for the AirSafe. So I am going to end the first poll, and we'll look at the results from our second poll, which talks about the difference between the 515 and 525. And it seems most of us were aware of this difference. So that's a good thing. And for those of us who didn't know the difference, make sure that you're always looking out for these differences. So if you have a 515 and a 525, normally on the sides of the control board, it's written somewhere that this is a 515 model, 525 model. So you just need to be extra careful when doing the changes.
Thank you very much, Maui, for that. Do we have any comments or questions? Okay, so we move on to our next question. And our next question reads, hello, I'm working on a DeVilbiss 525 that is producing low purity. I serviced the compressor and refilled the seat beds and put the concentrator on a 2 hours test. After running for an hour, the concentrator shut down and became very hot. I found that the fan was stuck and I replaced it with a new one, but the overheating problem persisted. How can I solve this problem? So I'll ask one of our technicians to respond to this question. We have a hand from Eunice. So Eunice, you go ahead.
Okay, thank you. Oxygen concentrators make use of compressors to generate pressurized air for the purification process. Compressors tend to experience a rise in temperature as they operate, so they need a fan to cool them off when the temperature rises. The DeVilbiss 525 has its fan mounted beneath the compressor to aid in cooling it when it gets hot. A defective fan will cause the thermal switch connecting to the compressor to open the circuit and hence turn the machine off due to the rise in temperature. When you realize you have a clogged fan and are about to replace it, make sure you have taken note of the connecting wires and the position of the fan and the fan guard. The fan has an airflow directional arrow on the sides that show the direction in which air is supposed to flow in. Make sure this arrow is directed away from the compressor when installing the fan in its place. As we can see in the graphics, we are seeing a picture that has an arrow pointing in the rotation and where the airflow is supposed to go. So make sure before you replace, you take note of these arrows and don't just replace it anyhow. So the fan guard can then be replaced after you have properly installed the fan back in its place. Thank you very much, Naomi.
Thank you very much, Eunice, for that explanation. I hope we have all learned on how we can take care of our machines. It is really important. Two things that are really important are to check the ratings, but also to check the direction of our fans. So let's make sure we take note of that. We have a hand from Kelvin Saidi. You go ahead.
Okay, thank you, Naomi. So I have a comment, although it is not related to the 525 issues that Eunice was talking about, but I think it's worth sharing. So most of the AirSafe concentrators that are being manufactured these days, they come with a DC fan, and the fan gets its power from a board which has a transformer that steps down the AC voltage, and this step down AC voltage is converted to 12 volts DC. So there are times when the transformer fails, and this causes the fan to stop running. So when dealing with such concentrators, it is important to take note that there are times when the fan might be functional, but it is actually the transformer board that is damaged. So I would advise that when checking for almost all electrical components, if they are faulty, first check if the power being supplied to them is there, because we might make long conclusions and label something to be faulty when it is not. Thank you. Back to you now.
That is a very important insight, Kelvin. Thank you very much. Thorough troubleshooting is needed whenever it is that we're working with our machines before we write off some parts. So thank you very much for that wonderful comment. Do we have follow-up questions or comments? Okay, seems we have none, so we'll move on to our next question. Our next question reads, hello there, we have a J5 oxygen concentrator with no oxygen flow at the patient outlet port. When the machine has been turned on, how can we tackle this issue? So the machine is on, it's running, but then they don't have any flow at the patient outlet. How can they tackle this issue? So I'll ask one of our technicians to respond to that question. Okay, we have a hand from Paulina. So Paulina, you can go ahead.
Thank you, Naomi. The problem of no oxygen flow at the outlet port in oxygen concentrators is tackled in stages. You have to see if there is oxygen flow at different stages of the oxygen concentrator. The stage where you find no oxygen flow is where your problem is, and you can go ahead to rectify that problem. The very first thing to check is the patient outlet fitting, which may be the one that is restricting the airflow. If there is no blockage, you can proceed to move inwards, and the next step is the check valve. The J5 does not have a check valve connected between the outlet and the flow meter and the oxygen outlet. But for other models of concentrators that have the check valve, it should be checked. The function of the check valve is to allow airflow in one direction only. If the check valve is blocked inside or its direction is reversed, there will be no oxygen flow. After the check valve, you can proceed to check if the flow meter is open. If it is not, there will be no oxygen flow. Sometimes the flow meter may have some leakages or some breakages, and this will cause heavy leaks, and if spotted, then these issues need to be fixed. You should also check oxygen flow from the product tank by just removing the outlet tubing and then observing the oxygen flow. The inlet of the flow meter in the J5 is fed from the product tank via the bacteria filter. If the bacteria filter is blocked inside by dirt or any debris, it will not allow flow of oxygen, and there will also be no flow at the outlet. If it's blocked, then you have to replace it. You can also check the pressure regulator to make sure that it's not completely closed. If there's no flow from the product tank, then you proceed to check the sieve beds. You have to disconnect the tubing between the sieve beds and the product tank to observe if there is any oxygen flow from the sieve beds. At this stage, if there is still no flow, then you know that either the valve or the compressor is at fault. You need to disconnect the valve from the sieve bed to check if there is flow in the valves. If there is no flow, check the integrity of the valves. If there is nothing wrong with the valves, then it means the compressor is at fault. If the compressor is running properly, then it means the intake hose of the intake hose is not connected to the compressor, or there's an obstruction in the intake path of the compressor, which is restricting the airflow. The compressor of the J5 is housed in an enclosure. You have to unscrew all the screws to have access to it and rectify the problems. Thank you, and over to you, Naomi.
Thank you very much, Paulina, for that wonderful response. You have taught us the outside-in principle, where we're looking at the outlet first and then going back to the other components inside the concentrator. So thank you very much for that wonderful response. We have a poll at the end of the question, so I'll ask Maui to launch the poll.
Thank you very much, Naomi. So I will be launching our next poll, which also happens to be our final poll of the core. And our poll reads, have you ever encountered an oxygen concentrator with no flow when the machine has been switched on and the compressor is running? Have you ever encountered a machine that has been switched on, a concentrator with no flow when the machine has been switched on and the compressor is running? So I am going to leave the poll open for a few seconds for people to vote. Okay, so far it seems most of us have ever encountered this problem before, but then still, we have a few technicians that haven't encountered this issue before. So I guess now, if you happen to have encountered a similar issue, you're going to know how to deal with it. I remember one time when I was at Neno District Hospital, we were fixing oxygen concentrators, and there was a machine that was that stayed idle for quite some time. It's had an issue of a top plug, I think. So we fitted the top plug, switched the machine on, tried to open the flow meter, and we didn't get any flow. And upon troubleshooting, we realized that a wasp had built a nest inside the patient's outlet. So it was completely blocked and there was no way for the oxygen to flow. So yeah, sometimes you just need to have a closer look and then you'll be able to find these issues. So I'm going to end the poll now and I'll hand it back to you, Naomi.
Thank you very much, Maui, for the poll, but also for that experience that you've shared with us. Next time we're faced with such a problem, we are going to take a closer look at everything. So looking at our time, it looks like this should be the end of our call. A reminder to those that are just joining us, be sure to share with us your contact details in the chat so that we add you to our emailing list and that you'll be able to get notifications of when next we have our next meeting and calls. And if you're just joining us, you might as well send your questions if you have any that are in regards with the oxygen concentrator, maintenance, its assessment and use through our email info@oxygenalliance.org. You can also visit our website if you want to know more about the work that the Oxygen Alliance does. You can visit our website at www.oxygenalliance.org, and there you find all the work that we do outlined there. We also have a YouTube channel where the calls are normally posted, so be sure to visit our channel so that you can follow up on the calls that we've had in the past. There, you can also subscribe so that you can be able to get notifications, and don't forget to also hit the notifications bell for you to be getting the notifications whenever we post new material. So we also have videos of various aspects of oxygen concentrators, maintenance and their use posted there, and troubleshooting, you can also find them there. So be sure to visit our YouTube channel as well. Next week, we are also going to meet at the same time, same place, 2:30 to 3:30 p.m. so that we can also have another call where we answer various questions, but also have a topic of interest that we're going to be talking about. Thank you very much for staying with me there, and bye. Have a lovely week.